Sometimes we end up with an expression somewhere in our work that's a product of the cosines of two different angles. This is a product. This is times cosine alpha times cosine beta. And when that happens, it would be really nice to have a formula that lets us deal with that situation. So let's see if we can find a way to build such a formula. If I take cosine alpha cosine beta plus sine alpha sine beta, I know that that comes from the difference formula for cosine. And cosine alpha cosine beta minus sine alpha sine beta sine beta comes from the sum formula for the cosine. Cosine of alpha plus beta. If I then add these two together, I get two copies of cosine alpha cosine beta, 2 cosine alpha cosine beta, but the plus sine alpha sine beta and minus sine alpha sine beta cancel each other out. And I get here cosine alpha minus beta plus cosine alpha plus beta. Now I'm going to divide both sides by 2. I don't know if you notice what happened here is I got 2 cosine alpha cosine beta. Cosine alpha cosine beta is exactly what I want. So I'm going to divide both sides by 2. Then I end up with cosine alpha cosine beta. The product of the cosines of two different angles is equal to cosine of alpha minus beta plus the cosine of alpha plus beta, all divided by 2. And this is the format that your textbook used for reduction formulas, but for this type of formula, for some reason, it's rewriting this as 1/2 of the cosine of alpha minus beta plus the cosine of alpha plus beta. So here, with some manipulation, is a new formula for you. We have the cosine alpha times the cosine of beta is equal to 1/2 of the cosine of alpha minus beta plus the cosine of alpha plus beta. A formula like this might be useful when alpha minus beta is a known angle like pi over 6 or pi over 4, and alpha plus beta is a known angle. But alpha and beta themselves are not, okay? So this type of formula might be useful when the result of subtracting two angles or adding two angles is a known angle. So this is the formula for converting the product of two cosines of two different angles, into a sum of two different cosines. These are still two different angles. Alpha plus beta is one angle, alpha minus beta is a different angle, but we're now working with a sum. There is also a formula for the sine of alpha times the sine of beta, but we're going to talk about how that one is built in class. It uses similar algebra. So let's move this one up here. I'm going to have a couple to add to our list here. This is our product of cosines formula, our product of sines formula. Oops. Sine alpha sine beta is equal to 1/2. I think in the interest of space, I'm going to delete this version of the formula and just stick with this one. That's what we have in our textbook. Just know that you can write it either way. It's certainly fine with me, and it's algebraically equivalent, so it really doesn't matter. And this will save us a little bit of space. All right, put this over here, and then this part, and then this part. Okay, and then I can continue with my sine formula. The sine of alpha times the sine of beta is 1/2, it should look familiar, times the cosine of alpha minus beta minus the cosine of alpha plus beta. But what if we have the sine of one angle times the cosine of another? Well, that has a formula too. That is the sine of alpha plus beta plus the sine of alpha minus beta. And the sine of beta times the cosine of alpha, or the cosine of alpha times the sine of beta. I think that's how your textbook has it. That's equal to 1/2 times the sine of alpha plus beta minus the sine of alpha minus beta. Now there are a couple of things to observe here. Your textbook puts these in this order. It gives the cosine times cosine formula first, then the sine alpha cosine beta formula second, then it gives us the sine times sine formula next. These are actually the same. It gives us the cosine alpha sine beta last. I put them in a different order. I grouped these two together and these two together because these two are the same formula. It's just that with two cosines, you need a plus here, and with two sines, you need a minus here. So for me, this grouping makes more sense. You do whatever you need to make it make sense to you, but that's why I've grouped them a little bit differently. The sine times cosine, and cosine times sine formulas are the same, except that one has a plus and one has a minus. The other difference is that in the first two formulas, the alpha minus beta comes first and the alpha plus beta comes second. In the second two formulas, well, in the second and fourth formula in your textbook, the alpha plus beta angle comes first and the alpha minus beta comes second. That's an important observation to make because two of our formulas have minuses in them. We can't just reverse the order of the terms. We can't say that this angle the cosine of this angle minus the cosine of that angle is the same as the cosine of the sum minus the cosine of the difference. It's not. Remember, alpha plus beta is an angle, and alpha minus beta is a different angle. So I'm taking the cosine of an angle, and I'm taking the cosine of an angle, and I'm subtracting the two. The cosine of an angle is a ratio. It might be 1/2 or square root of 3/2, or it might be 2.7. Whatever number it is, that number minus this number is not the same as this number minus that number. So it's important that we get these, whether this is alpha minus beta in the first position and the alpha plus beta in the second position, it's important that those are in the right place. And the same is true of this formula. So for me, to make it easier to remember, that the product of two cosines and the product of two sines are the sums of cosines, and the product of a sine and a cosine, or a cosine and a sine, are the sums or differences of two sines. Okay, how might we use this? We might, for example, be asked to find the cosine of pi over 4 times the sine of pi over 6. Well, we can certainly use the formula on this one, but we don't need to because I know what the cosine of pi over 4 is. It's 1 over the square root of 2. And I know what the sine of pi over 6 is. It's 1 over 2. So my result, this is going to be 1 over 2 root 2. And if you want to, you can rationalize the denominator, but I don't care about that. So here's my answer. I don't need a formula for that. But what if I was asked to find the cosine of pi over 4 times the sine of pi over 12? Well, pi over 12 is not an angle I know the sine or cosine for. So now I need a formula. Now I need something to help me out, right? I need something to help me reconfigure the situation. Here what I have is a cosine of alpha times sine of beta, and that's this one right here. Let me grab a different color highlighter because I'm using cosine of alpha times the sine of beta. So I need this formula here in order to do that, recognizing that my alpha in this case is pi over 4, and my beta is pi over 12. This is going to be equal to 1/2 of the following. The cosine of pi over 4 plus pi over 12 minus, sorry, that's a sine. My apologies. See what I mean about recognizing when you made a mistake? That's a sine. And then here I have minus the sine of pi over 4 minus pi over 12. Okay, let's move that up a little bit. Can it be done? Yes. All right, that's going to be equal to the sine of, now I have to do some arithmetic here. What is pi over 4 plus pi over 12? and then the sine of, there's a little more arithmetic to do there. So let's do that up here. Pi over 4 plus pi over 12. And we'll also need to do pi, give myself a little more room there. Pi over 4 minus pi over 12. Now, I'm going to need a common denominator, so I'm going to multiply my first fraction by 3 over 3. And that's going to give me 3 pi plus pi over 12, which is 4 pi over 12, which is pi over 3. So that's what goes in here. And this is going to give me 3 pi minus pi over 12. That's 2 pi over 12, or pi over 6. So that's what goes in here. So now all I have to do is take those signs. What is the sine of pi over 3? It's the square root of 3 over 2. And now I'm going to subtract the sine of pi over 6. Well, that's a half. So I have square root of 3 minus 1 all over 4. I just did a little bit of, I multiplied that, I combined these to have a common denominator of 2, and then I multiplied by a half, or multiplied, or divided by 2, so that's how I got the 4. So that's my answer, and that time, I didn't really want to use a yellow highlighter, that's okay. That time, I did need the formula, because I don't know what the sine of pi over 12 is. So that's an example of when you see something in this form, doesn't necessarily mean you're going to need a formula to deal with it. But if you do, then this is the kind of formula that you might want to use. So that's how you express the product of two trigonometric functions as a sum of two trigonometric functions. But let's take a look at how you might express the sum as a product. That's our next video.